quiz, and you'll have 8 questions total. The questions will be this. Let me tell them to you. You're going to have a confidence interval for a proportion. You have a confidence interval for a mean. And then you're going to have a confidence interval problem where you need to find n. And it'll probably be for a proportion. Find n for a proportion, because that's more reasonable than for the mean. And then, so that's your Chapter 7 problems. For Chapter 8, you're going to do a hypothesis test for a proportion, hypothesis test for a mean. And then for Chapter 9, you're going to have a 2-sample hypothesis test for a proportion, 2-sample hypothesis test for a mean that's independent, and 2-sample hypothesis test for a mean that's dependent, like this one we're doing now. So that's 8 problems you guys are going to have. You're going to have one of each of those. That's your test. So if you do the wrong thing on a problem, if you do the kind of the right thing on the wrong problem, if you're a doctor and you do a perfect surgery and you remove somebody's whatever, but you do it you do an ACL surgery, but you do it on the wrong leg, even though it's a great surgery, that's totally messed up, right? You have to do the right thing on the right thing, if that makes any sense. So, it's really important. So that's why we're going to spend probably 20 minutes, 15, 20 minutes going over, maybe only 15 minutes, going over how to figure out what kind of problem you have and making sure you can identify problems correctly, because that's super important. And it's something that students typically really struggle with. Especially this one here, this 2-sample dependent one, where you have, you can see they're matched up, right? They're all in these matched up pairs. That's how you know it's a 2-sample dependent. When they're matched up in pairs, you subtract them and you do a 1-sample t-test on their differences. So let's go and go through this first. Are there any other questions about this before I start? Okay, so here, the claim is she wants to see if a person's cholesterol remains the same, right? So in other words, mu1 should equal mu2. So your claim is that mu1 equals mu2. For these, you write this as mu1 minus mu2, because we always do this, the dependence, we always do mu1 minus mu2 because we're talking about, we're going to subtract them and take their differences. So once we subtract them and take their differences, mu1 minus mu2 is going to be, if they're equal, I have no idea what I'm doing. If they're equal, then they're going to be, when you subtract them, what you get should equal 0. So that's my claim. My claim is that their differences, the mu d's, equals 0. So you look down here, my H naught always equals. For the 2 samples, it will be 0 equals 0. You can also write it as mu d equals 0. Either one, they're the same thing. mu1 minus mu2 is mu d. That's my claim. So here, H naught is my claim. You're going to have one problem on the exam where H naught's your claim. This is how you handle it. When H naught's your claim, you're doing the whole test to either reject or not reject your claim. So in step 5, you're going to use the word reject. So you should write reject in the parentheses. Whenever H naught's your claim, you're going to use the word reject. Typically, H1 will be your claim and you'll use the word support. But on those rare instances where H naught is your claim, you're going to use the word reject in step 5. H1, since H naught is your claim, then H1 becomes the opposite, not equal to. So mu1 minus mu2 is not equal to 0, or mu d is not equal to 0. Okay, so then this is a two-tailed test because we have not equals as our H1. So we're going to draw our little picture. We're going to shade both ends. It's going to be two-tailed, and our degrees of freedom, it's a mean, right? It's a mean Mr. T distribution. We have 1, 2, 3, 4, 5, 6 of them, so degrees of freedom is 6 minus 1, or 5. Two-tailed. So I'm going to grab out my handy-dandy T-table, and I'm going to look for alpha two-tailed test. Is it 0.05? Is that my, yep, alpha's 0.05. So it's this third column here, and I go down to degrees of freedom 5, and I get 2.571. So 2.571, is what we're going to grab here and put that in as positive and negative 2.571. So negative 2.571 over here, positive 2.571 over there. Then your test stat. You're going to put these numbers into your calculator, these differences, or you could put the first list and the second list and subtract them, but it's just as easy just to subtract them. It's not that hard. So put these numbers into your calculator and do into a list and do stat calc 1 bar stats on them, and you'll get your X bar D. Your X bar is 16.7 and your S is 25.4. You might say, well, how come in my quiz we rounded to, we had 3 decimal places and here we only have 1? It all goes back to our data. Our original data has no decimal places. You guys see this? It's all whole numbers. So our mean should have 1 decimal place. In our quiz, our data had 2 decimal places. So then for our X bar and our S, we use 3 decimal places because they should have 1 more than your original data is in. But honestly, as long as you do 3 sig figs, I'm not going to complain. I need 3 sig figs at least. So give me 3 sig figs and you're fine. I'm not giving you specific. Yeah. Vanessa?
So for step 2,
yes.
So for step 2, are you going to want us to write out whether it's 2 tails or 1 stump and then the degrees of freedom as well?
Nope, I'm just writing this because you need to know that. As long as you get this number correct, then you're fine. So you could just write the critical value equals positive negative 2.571 and draw your picture, and that's okay. But if you do write this out and then you screw it up and pick the wrong thing on the table, then you'll still get pretty much full credit if you've written out 2-tailed and degrees of freedom equals 5. But, you know.
Did you want us to write which one is our claim?
You don't have to, but if you screw this up down here, then you'll run into trouble. So no, you don't absolutely have to. It does, actually yes, I do want that, because then I know what you're thinking, and I know if you screwed something up. So that will help me a lot.
I'm sorry, I missed that part. What was the question?
She said, I want you guys to write down which one is the claim, whether it's H0 or H1, and I do. I really kind of do want you to write that down.
Okay.
Okay, so then my test stat's going to be my X bar 1 minus 0, because remember, X bar 1, that's my claim, it's from my sample, and then this part here minus whatever's in my claim. 0 is in my claim, so minus 0, over S, 25.4 over square root of n. I have 6 of them, so square root of 6, and should get 1.61. So put that in here. If you did 3 decimal places, that's fine, I don't care. Doesn't matter, it's all good. At least 3 sig figs. So pop that in. That's clearly in the do not reject area, not guilty, not enough evidence. So we do not reject H0, which means that we do not have enough evidence. Remember, whenever we're not on step 4, we're not on step 5 as well. They either are both nots or they both aren't, but they will match up with each other. So not enough evidence to blank the claim that cholesterol levels remain the same between before and after treatment. So here, because H0 is my claim, I'm going to use the word reject here. If you put the word support here, you're going to lose 2 points. Okay. We good to move on? Ignore that. That was not useful. All right. So now we're going to take a look at proportions versus means. So how do you know it's a proportion or mean? You know it's a proportion because it doesn't say mean or average. That's the easiest way. A mean will always say mean or average or be a mean in disguise. So it'll have an X bar or a list of data that are numbers. Whenever your data are numbers, then that's a mean. Whenever your data are yeses and nos, that's a proportion. So a proportion will also be when you have percents or fractions as the things that you're comparing as well. Those are kind of the main things. On the exams, I'll expect you to state what H0 and H1 are, find your critical value, and draw a picture. Find your test stat, your test value, including writing the formula with the numbers in them. and then decide to reject or not reject H naught and summarize your results for your claim. So just what we've been doing in all these. Now, next question is it a confidence interval or a hypothesis test? You need, like I said, it's really important you know how to tell the difference between these two. A confidence interval will always say either estimate or confidence interval. Not confidence, but confidence interval. Estimate or confidence interval. It will always say one of those two. The hypothesis test will not say one of those two. And often it will have a word like test or claim or conclude. Not always, but often it will. But more importantly, it will not say estimate or confidence interval at all. That's how you tell them apart. Same with the mean, like your means and proportions. Means will always say proportion. Means will always say mean or average. Confidence interval will always say confidence interval or estimate. Always. One sample or two samples. Find the actual word sample or sample in disguise, which would be like selected or surveyed, and then see how many groups were actually sampled. If you find your sample size, that's the key, because sample size will always have, that will be a sample, right? If you only have one sample size, then you only have one sample. If you have two sample sizes, then you can have two samples. All right. And then I also want to talk a little bit about confidence intervals because it's been a long time since we've done them. So I added in a step 0, which is finding your best point estimate. Right, remember your best point estimate point is one number. So find your best one number estimate. So your best guess, if I'm estimating, is say I want to know the average height of all men in the United States. So I will take a sample of men in the United States and say I get 67.3 inches. Then my best guess for the average height of all men in the United States is going to be what I got in my sample, my X-bar, 67.3 inches. So your X-bar, whatever you get for your sample mean, or if it's a proportion, your p-hat, your sample proportion, that's your best guess at what the true proportion is. So that's your best point, one number point estimate. So find that first, and then find your critical value, looking up on the t-table. If it's a mean z-table, it's a proportion. Right? Remember, easy peasy, proportion z, mean Mr. T, means go T for the t-table. And then find your margin of error, E. So this Z critical value, that's really means critical value. So critical value times the square root of P hat Q hat over N, or if it's a mean, your critical value times S over square root of N. So really, this critical value really is what should be in here, and you can kind of see that's the part you pay attention to, the critical value part. Okay. This just says what's a z-table, a z-score, or a t-score. All right, then calculate your interval, right, for proportion, p-hat plus or minus e, or for a mean, x-bar plus or minus e, and then draw a picture. So you might draw your little picture here, and then remember you're going to shade, you'll have your outside areas, and then you'll have whatever you get for the lower and upper limits. And technically this is for a mean, so I should probably move that over. It should be over really on the right side, but just your picture looks something like this. So that's the confidence interval, just as a quick reminder. All right, so now I need you guys to don't solve these, just identify what type of problem they are. Whether it's a mean or a proportion, whether it is a t-table or a z-table you're going to use, and whether this is a test, hypothesis test, or a confidence interval. So someone start reading right here. You know what I'm going to do is I'm going to pull up this here. So you don't get messed up. Start reading with a medical investigator claims. So Vanessa, since you're unmuted anyways, go ahead and read.
A medical investigation claims that the average number of infections per week at a hospital in southwestern Pennsylvania is 16.3. A random sample of 10 weeks had a mean number of 17.7 infections. The sample standard deviation is 1.8. Is there enough evidence to reject the investigator's claim at A equals 0.05? try doing this with machine calculator which function.
Yeah. All right, so don't solve it. Just tell me whether it is a mean or a proportion, whether you're going to use a t-table or a z-table, and whether this is a hypothesis test or a confidence interval. So take 15 seconds on your own and try to figure that out. Okay, so is this a mean or is this a proportion? What do you guys think? Look for the word mean or average. Yeah, see the word average right here? So it's a mean, you know it's a mean. Is it a t-test or is it going to be a t-table then or a z-table? T, yeah, mean Mr. T, so it's going to be a T, and then is it a confidence interval or a hypothesis test?
Hypothesis test.
Hypothesis test. How do you know? Because, what was that?
It doesn't say estimate or confidence interval?
Exactly. It doesn't say estimate or confidence interval anywhere. A confidence interval will always say confidence interval or estimate, always. Also, it says evidence and reject and claim, which are sort of hypothesis test words. I'm talking about claims here. Okay, good. So again, it's going to be a mean because it says average and mean. So mean Mr. T, t-table. Great. Let's take a look at the next one. Oops. Uh-oh. Great. Jay, can you read this one?
Food consumption. The nutritionists found that in a random sample of 80 families, 25% indicated that they ate fruit at least 3 times a week. Find the 99% confidence interval of the true proportion of families who said they ate fruit at least 3 times a week.
Great. All right, 15 seconds. Is it a mean or a proportion? Z or T? Hypothesis test. Well, let's start with those two first. And then hypothesis or confidence interval if you can. All right, so mean or proportion, which one is it, guys? Yeah, proportion. Right, it literally says proportion. Nowhere is the word mean or average. And also there's this percentage, right? Not the 99% confidence interval, but the percentage that's not, 90, 95, or 99. And then, so proportion, so is it going to be a T or a Z?
Yeah.
Easy peasy, so PZ, proportion, Z. Z table. And then is it a hypothesis test or confidence interval?
Confidence interval.
Uh-huh. So confidence interval, because it literally says confidence interval, right? So so it's going to be a confidence interval. It actually physically says confidence interval. Confidence intervals will always say confidence interval or estimate, one of those two. Okay, so it's proportion, because it's a proportion, easy peasy, it's a Z, and it's a confidence interval, because it literally says that. Next, Chris, go ahead and read for us.
For a specific year, the average score on the SAT math test was 515. The variable is normally distributed, and the population standard deviation is 100. The same superintendent in the previous example wishes to see if her student scored significantly below the national average on the test. She randomly collected 36 student scores as shown at alpha equals 0.10%. Is there enough evidence to support the claim?
Yep. All right, so is it a hypothesis test? I'm sorry, is it a mean or proportion? Z or T?
Me.
Hypothesis, just try to figure out, or a confidence interval or hypothesis test. Take 15 seconds, go. And try to work these out because this is the hardest part of the exam. Okay, is it a mean or a proportion? Mean, yep, because it says average. And then also, average, but also you have a list of data that's numbers. Whenever your data is numbers and they give you a list of data, then that's when you have to find the mean yourself. We expect you to find X bar and S on your own from this list of numbers. I won't give you a list that long, but whenever you're expected to find your own X bar, that's a sample, that's a sample mean. So those are means. So is this going to be a T distribution or Z distribution? Mean Mr. T, so yep, T distribution. And then this is a hypothesis test or a confidence interval. It is a hypothesis test because nowhere in here is the word confidence interval or estimate. And again, we have some evidence and we have a claim. You're only going to have evidence and claim if it's a test. So mean Mr. T, so it's a T distribution, and then hypothesis test. Great. Samantha, go ahead and read.
According to a professional polling company, an unbelievable low percentage, negative 36% of all Americans said they were fans of professional baseball. A random sample of 200 people indicated that 88 were baseball fans. At alpha 0.01 is the proportion greater than 36%.
Right. This means low percentage. In other words, 36, not negative 36%, just 36%. Sorry about that. That was confusing. So, my bad. All right. So is this a proportion or a mean, Z or T, confidence interval or hypothesis test? You do not have to show your work on calculating mean and standard deviation of a sample. No, you just have to be able to do it. Yes. All right. So this is a proportion, right? Because it literally says proportion and also no mean or average in there. So is it a Z or a T, guys? Z, proportion, easy peasy. Good. Is it a confidence interval or hypothesis test? Confidence interval, hypothesis test. Where is the word confidence interval? Do you guys see the word confidence interval in here somewhere?
No.
There's no word confidence interval in here at all, no phrase, and no word estimate. Estimate is not in there. There's no estimate or confidence interval. They don't exist here. So this is a hypothesis test. Anytime you don't have confidence interval, literally the word confidence interval or estimate, then it's a hypothesis test. Okay.
For this one, what would your claim be?
Greater than. Is a proportion greater than 36? So your claim would be that it's greater than 36.
Got it. Thank you.
Yeah. Does that make sense for folks? So that was a good question. Is the proportion, also it'll have a question. So hypothesis test will have a question, and confidence intervals will only have a question if they're asking you to find your sample size, which is not, it's not asking you to find a confidence interval, it's asking you to find how large your n, what your n should be. So because there's this question, and that's either a hypothesis test or it's that subset of the confidence interval of finding the n. Okay, next one. Michael, go ahead and read. Or Ian, go ahead and read.
Given that we want to estimate the mean IQ scores for the population, how many specific students must be randomly selected for IQ tests if we want 95% confidence that the sample mean is within 3 IQ points of the population?
Great. Okay, 10 seconds, everybody. Mean and proportion, Z or T, hypothesis test or confidence interval. All right, so is this a mean or proportion? Yeah, it says mean right there, so it's clearly a mean. Is it a Z or a T then? Mean, Mr. T, T distribution. Is it a confidence interval or a hypothesis test? Which one is it? Confidence interval or hypothesis test?
Confidence interval?
It says estimate. Do you guys hear it says estimate? Whenever it says estimate or a confidence interval, that's a confidence interval. So this is a confidence interval, but see how it has a question? Confidence interval with a question? That's when it says you gotta look for how many students. This is a find n problem. So this is one of those kind of odder ones. I'll show you what I'm talking about here. Right? So it's a mean, T, right? But because this estimate is a confidence interval, we were asking how many students must be randomly selected if we want to be within 3 IQ points. So because it's a mean, because it's a confidence interval with a question, then this is one of those find n problems. How many? Asking how many do I have to sample? How big should my n be? So this is a find n, which means that I have to give you E. I have to give you the error. Remember, the error is when you find either the word error or you find the word within, that's your error. I have to give you the error if I want you to find n. Because I can only not give you one thing. So I either have to give you the n or I have to give you the error, one or the other. If I give you the n, then you need to find the error and find the confidence interval. If I give you the error, then that's the weird one where I'm asking you to find n. And this is that weird one when you're supposed to find n. Okay, so let's go ahead and go to the next one. Oops. Let's get Edgar. Go ahead and read this one. Edgar. And how about Jackie? Jackie, go ahead and read for us.
A researcher wishes to test the claim that the average cost of tuition and fees at a 4-year public college is greater than $5,700. She selects a random sample of 36 4-year public college and finds the mean to be $5,950. The population standard deviation is $659. Is there evidence to support the claim at alpha equals 0.05?
Perfect, thank you. All right, so again, is this a mean or a proportion? Is it a Z or a T table we're going to be using? And is it a hypothesis test or a confidence interval? 10 seconds. All right, which one is it, guys? Yep, mean, you see the word average there? Great. So then it's going to be mean Mr. T, T distribution, right? Is this a confidence interval or a hypothesis test?
Hypothesis.
Right. Because if you look here, there's no words. You cannot see the word confidence interval or estimate anywhere. Let me go ahead and scroll. 23. There we go. There's no estimate or confidence interval anywhere. And also, there's this word about evidence and support and claim, right? So those are kind of all in there. All right, here's another one. Researchers are conducting trials. They're asked to think of Alright, creative use of blah, 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 research was given. Okay, here it is. Construct a 95% confidence interval estimate for the difference between the mean creativity score for those with the red background and the mean creativity score for those with the blue background. What kind of problem is this?
Confidence interval.
Okay, it's a confidence interval because it says confidence interval. Totally. Is it a mean or a proportion?
The mean.
Yep, it says mean. You guys see mean here? So mean. So it's a mean, so it's going to be a Z or a T. Which one? Yep, T. Mean Mr. T. Also, how many samples are there? So you have 2 samples. You have 2 samples, and is this independent or dependent? Independent or dependent? Independent, yeah, because I didn't give you 2 lists of numbers. Dependent, I have to give you 2 lists of numbers that match up. Since I didn't give you 2 lists of numbers that match up, this has to be independent because you have to be able to see the 2 things side by side and subtract them in order for it to be dependent. So this is an independent 2 sample. Alright, so in other words, it's going to be where you use this formula right here. Independent samples, you have 2 independent samples mean. If it was dependent, then you subtract them, you subtract the top from the bottom, and then you just have then it's just like a 1 sample t-test. Then you treat it like it's 1 sample, if it's dependent. Okay, good. Edgar, you here yet? Can you call, or Edgar or Michael? You guys back? Either one?
I'm here.
Go ahead, read.
Example, female gun owners. The Gallup Crime Survey stated that 23% of gun owners are women. A researcher believes that in the area where he lived, the percentage is less than 23%. He randomly selects a sample of 100 gun owners and finds out that 11% of the gun owners are women. At A, 0.01 is the percentage of female gun owners in his area less than 20%.
Right. So guys, is this a mean or proportion? You see the word mean or average in here?
No.
No, it's a proportion. Right? And now you can see percentage. So it's a proportion. So it's going to be Z or T. Easy peasy. Proportion Z. Good. Is it a confidence interval or hypothesis test?
Hypothesis.
Yeah. There you go. Oh, wrong one. My bad. Hypothesis test. Because there's no word estimate or confidence interval in here anywhere. Great. Okay, so are you guys getting this? Should we can we kind of move on? Is that you guys have enough, or you guys want to do some more? Okay. Guessing you guys are done with this.
I think we're good.
Okay. All right. It's important that you guys see these, right? This is a confidence interval. It says confidence interval on it, and it's a mean because it says average. Incidentally, this one, how many samples is this one? So here's the thing. I think I circled it here. Let me take a look. See where it says random sample of 35? So here's my N that has a mean of this, standard deviation of that. These are my sample. This one here is not a sample because it doesn't say, first of all, it doesn't say sample. Second of all, it doesn't have an end. It has a mean, but it doesn't have an end or a standard deviation. So this one is your mu. That's how you know this is the one that's going to be in your claim. It doesn't have an end. If it doesn't have an end, it can't be your sample. It has to be your mu instead. All right, so let's go ahead and let me pop into what we have here. I won't torture you guys as much. Okay, So here's kind of one last one we want to take a look at. So here, this, let me find it, actually. There we go. All right. So what kind of problem is this one? This one last one. Everybody read it. Allie, why don't you go ahead and read it?
A researcher wishes to be 95% confident that her estimate of the true proportion of individuals who travel overseas is within 4% of the true proportion. Find the sample necessary if, in a prior study, a sample of 200 people showed that 40 traveled overseas last year. If no estimate of the same proportion is available, how large should the sample be?
Good. So, proportion or mean, guys? Proportion, good. Yep, it says proportion. So it's going to be a Z distribution. Is it a confidence interval or a hypothesis test?
Confidence interval.
Yeah, it literally says estimate. Whenever it says estimate, that's a confidence interval. Does that make sense? Estimate or confidence interval means it's a confidence interval. But there's a question. Do you guys see the question here? So if it's a confidence interval with a question, then it's going to be a find n problem. Find the sample necessary. Right? So if I'm going to take a look at situation of, let's assume we're going to look at the bottom one. If no estimated sample proportion is available, how large should the sample be? This is a find n problem. So that means I have to give you the error. Within, find the word within, you find your error, or you find the word error. Sometimes it's called error, within an error, an error of blah, blah, blah. So 4%, so my error is 0.04. No estimates given, so that means that my p hat and q hat are both 0.5. My critical value, let's see, 95% confidence interval. It's a proportion, so it's going to be a Z table. My critical value is going to be 1.96. So I'm going to jump to this formula here, which is in your handy-dandy sheet here, under proportion, minimal sample size, right? You might want to change that. You can write on this if you want and make that into a CV, critical value, instead of the Z alpha over 2. I'm totally fine with you changing that. But that's what it is, P hat, Q hat, times your critical values over E squared. So here I have my critical value over E squared times P hat, Q hat, 1.96 over error 0.04. Find that, square it, multiply by 0.5, and then round up to the next whole number. You have to round up because you can't sample a portion of a person. It has to be a whole person. All right, so we are going to solve some problems now. So let me go ahead and give you the first one. This is not in your handouts unless you happen to have downloaded this other sheet. I didn't have it in my handouts. So just what I asked you guys to do was bring a piece of paper and an empty sheet, and you don't have to write down the problem, just solve it. Show your work and solve this. This is problem number 1. So problem number 1, find your best point estimate, find the margin of error, and then find the confidence interval. Right? Find the 95% confidence interval. So find the best point estimate, find the margin of error E, and then find your 90% confidence interval. So take a couple